and I'm going to share my screen. At times when I'm doing this recording, I make a mistake, so I just hope I don't make a mistake today. Okay, assuming everything is fine, guys. Okay. By the way, so I'm going to take the pins to write here so you can see. But so we are talking about regression, right? Can you see what I'm writing?
Yes.
Regression. And I told you basically we have two main types of regression, which are simple regression and multiple regression. What's the difference? Yes, simple regression has just two variables, that is one dependent variable and one independent variable. Multiple regression has more than two variables, that is one dependent variable, somebody's on the door, one dependent variable and more than one independent variable, right? So last week we saw simple regression. We have not seen multiple regression yet, and I don't think we'll see it today. We'll continue with simple regression because I want to show you something. But basically, simple regression is like this, of the form y equals alpha plus beta x plus u, right? This a is, I'm just writing for alpha. So if you notice here, our dependent variable is y, correct? Independent variable is x. What is a, by the way? What is this a?
Constant.
It's a constant, or you can call it the intercept, right? What is u? Error term, or disturbance term, or residual term. And what is b? Of course. So b, we can call it the slope, or we can call it the coefficient of x. So this is the coefficient of that particular independent variable where the b is attached to, right? So this b here, it tells us the degree to which this x affects this y. Because in regression, we are trying to find out how the independent variable affects the dependent variable. So the coefficient of this x, which is b, which is actually the slope, it tells us how much x affects y. For instance, if I put 5 here, and let's assume that everything is in percentage. Let's assume we're using log, right? I told you with log regression, we express everything in percentage, right? So let's assume this is a log regression. So if I put here like ln x, and I put here, sorry, ln y and ln x. So actually here was b, but if I put 5 there, what does it mean? It means 1% increase in x will cause 5% increase in y, right? And I'm using percentage, both sides, because it is log. I've explained all of this. So you need to know what the coefficient is. So actually, that is what simple regression is all about. Just one variable. Now, why are we doing all these things? Why are we doing all this regression? These things are applicable in real life. They use them in real life. So today I'm going to show you an example of how it can be used in real life. Okay. So I want to talk today about hedging. Who has ever heard about this word? Hedging. What is hedging? Yes. Trying to reduce risks, right? Okay. For those of you who are doing investments, 503 with Koan Oja, and some of you have done 501 with Hatis Oja. 501. I'm sure you have seen this word somewhere. So in 503, what I'm saying now is not related to this course, but I'm just trying to give you an overview. In 503, there's what we call risk return trade-off. Have you heard of this? Kwanoja mentions this 1,000 times in his classes. I know him very well. What is a risk-return trade-off? The risk-return trade-off simply tells you that if your risk increases, then your expected returns should also increase. If your risk goes down, your expected returns should also go down. So there is a positive relationship between risk and return. That's a risk-return trade-off. Okay, now we don't like risks. Nobody likes risks, right? Everybody likes returns. So we try to reduce our risks. And a strategy we can use to reduce our risks is hedging. So hedging is like a strategy which investors can use to reduce their risks. It's like a risk mitigating strategy. Okay. Now, in financial markets, we have something like this. You will see all of this in investment. Spot price, futures price. Futures price / forward. What am I writing? Forward price. Have you heard about this thing before?
Yeah.
Okay. What's spot price?
It's the current price of price zero.
Sorry?
It's price zero.
What's price zero? What do you mean by zero? I know what you mean, but I want you to say it well.
The determined price in the market for the company that issued a stock or bond at the beginning. For example, they issued a stock.
Okay. And what's forward price?
Hmm?
What's forward price or futures price? When is the price determined in future? No. No. Yes, sure. You're correct that you missed one thing. Yes. Okay. So when do you pay? You pay now or you pay in future? No. That's where you got it wrong. Okay, let me explain to you what is happening. Let's say you go to the market to buy this pen. By the way, my pen does not have a top. I don't know why. Let's say you go to the market to buy this pen, and they tell you that this pen is 10 lira. 10 lira, right? And you want to buy the pen now. They tell you the price is 10 lira. That is the spot price. That is the price for immediate delivery. If you pay that price now, you get this pen now, 10 lira. So it is the price you pay for immediate delivery. But let's say you want this pen next week. The price of this pen now is 10 lira. But you don't want the pen now. You want it next week. But you're scared that when you want to buy it next week, the price has increased to 15 lira, right? So what you do is you go to the person selling this pen today and you fix the price with him today, but you don't pay today. You tell him that, okay, since if I want to buy this pen now, I'll pay 10. If I want to buy it next week, I'll pay 15. Let us try to fix the price today. Let's come to a compromise. So let's arrange a price of 12. So you fix the price today, but you don't take the pen because you don't want the pen now. You will take the pen next week. So when you come next week to take the pen, you will pay 12. And he will give you the pen, irrespective of what the price is. If next week the price is 15, it doesn't concern you. You will pay 12. If next week the price is still 10, it doesn't concern you. You have to pay 12. So what happens is that you fix the price today, but you don't pay today. You pay next week when you receive it. So it is the price which is fixed for future delivery. You get the difference? That's forward price. For futures and forward, for now, just assume it is the same. It is different, but assume it is the same for now. Let's not complicate it. Okay, now why do they do all of this? The price you pay for immediate delivery, we call that spot market, right? Spot market. So spot market is where you go and buy things and you pay immediately and you get them immediately. But if you are fixing the price for something to pay later, how do we call it? Derivative market. You will see all of this in 503 with Koan Hoja. Okay, what you might ask me is, you need it next week. So why are you fixing the price now? There are many reasons. Like I told you, one of the reasons is inflation. Maybe you are scared the price might increase next week. So you try to fix the price now, so that even if the price increases next week, you know that you have protected yourself, right? So it's some kind of hedging. Remember I told you hedging is trying to reduce risk. So there is a risk that the price will increase. So we are trying to fix the price now by getting into the derivative market to buy a forward contract or a futures contract, whatever, is some kind of hedging. So we are going to see how we can use simple regression to apply these kind of things. Okay, I have some slides here. So you see optimal hedge ratio. What is optimal hedge ratio? By the way, what is hedge ratio? If you come back here to, I told you hedging is trying to reduce risks mitigating strategy. Now, how do you know what portion of the instrument you should hedge for? These instruments can be anything. It can be commodities, it can be currencies, it can be foreign exchange, it can be anything you want to hedge, any instrument in the financial market. Now, you might want to take I'm trying to use some words which I'm not sure you understand. Things, something long position, short position. Do you know what it means? Long position. Short. For now, you might not understand it. You'll do it in 503, but let me just explain. If an investor takes a long position, it means he's buying something. If you take a short position, it means you are trying to sell something, right? So I have a way I always easily get it. Since buy, sell. Since the word short starts with S, I just assume it is sell, right? It's just some of my tricks I use to master these things. So if an investor takes a long position, it means buying something. Short position means sell something. Just understanding like that for now. So let's say you want to get into a long position. So let's say you want to buy a forward or futures contract. That is, you want to get to the derivative market to fix the price of something for future, right? So let's say long position, which means you want to buy. So you are trying to fix the price of something which you want to buy, which you will buy in future. Are you going to hedge the whole position, or are you going to hedge just part of it? How can you know what portion of that position to hedge? What can tell you is the hedge ratio. So this hedge ratio tells you the percentage of the position you should hedge, right? Now, you can hedge 5%, you can hedge 10%, you can hedge different percentage. But one of those percentages will have the least variance. I know you are getting confused. I'm sorry. Minimum variance. What is variance? Variance is risk. It's a measure of risk, right? So we don't want risk. So we want the option which has the lowest risk, the least variance. So that the hedge ratio which has the least variance, the minimum variance, is called the optimal hedge ratio.
This is the maximum hedge ratio.
Optimal. Don't use the word maximum. Use the word optimal.
Yeah.
The optimal hedge ratio is the least variance hedge ratio. It is the hedge ratio which gives you the lowest risk, the least variance. So if you can get the optimal hedge ratio and you hedge your position based on the optimal hedge ratio, then you have done the best hedge. Let me put it that way. By the way, are you guys understand what I'm saying? What should I explain? Okay. What is hedging? Hedging, you are trying to, by the way, it's recording, so you can watch it many times. Hedging, you are trying to reduce your risk, right? But what portion of your risks do you want to reduce? Do you want to reduce just 5% of your risks, or 10%, or 15%? So the optimal, well, not the hedge ratio will tell you the portion of your risks you should reduce, the hedge ratio, right? But you can have many hedge ratios. So which of them is optimal? Among the different hedge ratios you can calculate, one of them has the lowest variance. One of those hedge ratios has the minimum variance. That is the one we want. Because what is variance? Variance is risk. So we want to have the lowest risk possible. So we want to get the hedge ratio which has the lowest variance. And this hedge ratio which has the lowest variance, we call it the optimal hedge ratio. Fine?
I studied portfolio management last semester.
Okay.
And we have two types of hedge ratio. We have the minimum variance ratio and we have the optimal hedge ratio. So the minimum variance is the minimum risk that the investor can accept.
I understand what you're trying to say. I understand what you're trying to say. But for now, I don't want to complicate it because it can get more complicated than this. That's why I'm just giving you the basics. Then you study most of this in investments with Kohan Hoja. The reason why I'm just giving you the basics is because I want to show you how this is applicable in this course, right? That's why I'm telling you that what I'm telling you now is not related to this course. But I want to give you an idea so that when we are doing it, you are not lost. But I understand what you're trying to say. Ideally, minimum variance ratio is not the same. Technically, it is different from optimal hedge ratio. But for now, just understand it as the same because, well, they are similar, but there is a slight difference. So for now, just assume it is the same. You understand? Just like I'm assuming here that futures price and forward price are the same, but technically speaking, they are different, right? Okay. So if you have gotten that idea, now how is this applicable in this course? I have data here, which I downloaded already. Okay, if you see now here, futures. So all this data here under futures, and then we have data under spot. What is spot? By the way, these are prices here. These are stock market prices. So the spot price is the price for immediate delivery, correct? The futures price is the price you agreed today, but for delivery in future, right? So we want to use the futures price and the spot price to calculate the optimal hedge ratio. There is a formula to calculate optimal hedge ratio, but we are not going to use the formula because we are doing it with e-views, which is easy. But if you want to do it by hand, there is a formula which, anyway, let me not get into that. So I'm going to write the regression equation. By the way, guys, if you can see here, 2012 M02, what does it mean? 2012 M02, what does it mean? Month 2. This is monthly data. Remember, previously we used to work with annual data, but this is monthly data. So this is like second month of 2012, third month, fourth month, and so on, right? So we have monthly data from the second month of 2012 right up till the 7th month of 2017. Okay. So I'm going to import this data to eViews. I'm opening my eViews file. Oh my God. Let me close it. Save. No. Okay. I'm opening eViews file. So you come here to create dated regular frequency. We'll use it because it is regular frequency. But here, in place of annual, we are going to put monthly, right? So you change it to monthly. Now, what is the start date? I go back to Excel. The start date is 2012 M02. So I go back to eViews. All right, 2012 capital M02. And what is the end date? 2017 M07. Okay. 2017 M07. Fine. I just click OK. Now I need to import the data, right? And like I showed you, just write the command data, and you write the variables. We have two variables. spot and futures, right? But the way this, if you see that on Excel here, it is futures before spot. It's always good to write your variables the way they are on Excel, so that when you copy and paste, you don't face difficulties. So the first variable is future, which is a futures price, and we have spot, which is a spot price. So now I'm going to write there spot. Press enter, and I have my work file. What's the next step? Copy paste. Copy just the data. So I'm copying just the data. I have to paste it in the first cell, right? Paste. Wow, have I done? Okay, I pasted my data, so I can delete it. Delete. Guys, these are stock prices. We want to get returns. We don't want to work with prices. Do you know how to calculate returns from prices? Returns. I deleted it, but I wrote something here, risks and return. So actually what we are trying to do is we are trying to get the optimal hedge ratio, which will help us to hedge our risk. We need returns. We don't need prices. What we have here are prices. These are stock prices. But we need to get returns. So we need to convert these prices to return. Like this futures here is a futures price. This spot here is a spot price. Then we need to get the returns. So I'm going to generate. I'm going to generate. What's happening? Generate. By the way, you know this function, this command, right? Generate. I showed you how to generate lock using this command. So I'm going to generate. I want to generate the return for each of these prices for futures and for spot. So let me start with futures. I can just call it arrow futures. You can call it anything. Arrow futures meaning the return for the futures series. And how do I do it? Equals to 100 times, I'll explain, D log futures. What does this command mean? I want to generate arrow F futures. Arrow F futures is the return for the futures series. And this is the formula to do it. So what I'll do is, first of all, I'll get the logarithm of the futures. After getting the logs, I'll get the first difference. This stands for first difference. And then later, I'll multiply everything by 100 because I want it to be in percentage. You know, if you multiply by 100, you get percentage, right? So to convert prices to returns, what we are trying to do is we are first of all getting the log of the prices, and then you get the difference, the first difference of the log. That will give you the return, and then multiply it by 100 so that you get it in percentage. Does that make sense? So if I press enter, I get my return series here. This is my return series. So to get that of future price return, same command, generate arrow spot equal 100 times D log spot. So what I'm doing is I'm getting the log of the spot prices, then I'm taking the first difference of this log, I'll get the return series, then I multiply by 100 to get everything in percentage, right? Is it fine? By the way, if you are not understanding, you can ask me. Maybe you have a problem, you're not understanding something. Sorry? Yes. Sorry? How to get? I explained that, right? And I noticed most of you do not do it in the assignment. If you have negative values in the series, how to get a log. I explained that. I explained it in the videos. I did. I explained it in both videos, the first video and the second video. I don't have time. I have just, I have a lot of things I have to show you, but I don't have time. So just go back and watch the videos, right? Or you can see me after the class, I'll show you. Because I explained it, I recorded it. So you should watch the videos, it's there. Okay, guys, let's go back. We have no time. So now we have generated the returns of the forward price and the returns of spot price, right? Okay. We want to estimate this regression. Arrow spot is equals to alpha plus beta. Let me put here. Arrow futures plus error term. This is basic, right? This is basic regression. You know you have your dependent variable. This should be. You have your dependent variable, right? You have your independent variable. We have error term. A is constant, and B is the slope or the coefficient of these arrow futures. So when we estimate this regression and we get this value for B, this value for B will be our optimal hedge ratio. So it's very easy. Okay. So on E-views, can I remove this thing from here? Anyway, how do I estimate? What should I do? How do I do estimation? How do I do regression on E-views? What should I click? Tell me what to do. Sorry? I should press enter? Like how can you run a regression? How can you estimate something on E-views? I've shown you this thing. It means you did not watch the videos. That's bad. You are guessing. Guys, come to quick estimate equation, and then you have this page. In this page, you write out what you want to estimate, starting with your dependent variable. So this is our equation we want to estimate. So our dependent variable is arrow spot. So I'll write arrow spot. Next, I'll put a constant, and I'll write dependent variable arrow futures. I don't change anything here. I just click OK, and I get my coefficients, right? Now, this is our coefficients. 0.36 is the constant. 0.12 is the coefficient of arrow futures. So if I want to write now this estimated equation, what I can write is, I will replace, let me see, what are the coefficients again? Constant is 0.36. So here I will remove this A and put 0.36. And I'll remove this B and put, what is it? 0.12. 0.12. Now, how can we interpret this? Correct. I forgot. Thank you. When you do estimation, you eliminate error term. So, how can we interpret this?
This is 12%.
1% change.
Oh, okay.
1% increase in the futures. In the returns, it is returns, not futures price. In the returns of the futures series will cause 0.12. It is not 12%, it is 0.12. 0.12% increase in the returns of spot series, right? That's how we interpret it. Actually, this 0.12 is the optimal hedge ratio. So, optimal hedge ratio is 12%, right? 0.12 is 12%, right?
Yeah.
12%. So you see that we have applied regression in real life things. What you can do is you can go now to go online, download data for stock prices, spot price and futures price, maybe monthly data for some time, and then try to run a regression. But first of all, you need to convert these prices to returns, because we need returns. Once you get the returns of the spot series and the returns of the future series, run the regression where the return series, that is the spot returns, is your dependent variable, and then the futures returns is your independent variable. When you run this regression and you get this beta coefficient, that is the slope coefficient, that slope coefficient shows you the optimal hedge ratio, right? Okay. Now this 0.12 shows us the optimal hedge ratio. It also shows us the short run relationship between arrow spots and arrow futures. It shows us a short run relationship between the return of spot series and return of future series. Short run, not long run, right? That's fine. So I'm just trying to tell you how you can interpret these coefficients. Okay, guys, let me do something again. I'll go back now to e-views. I'll delete this. Remember, we did this estimation using return series. Look at here, we have futures, we have spots. These futures and spot are the raw prices. The raw prices. But we calculated returns from these prices because we wanted to calculate the optimal hedge ratio. To get the optimal hedge ratio, we need the returns, not the prices, right? And I've showed you how to interpret it. Now let's do a different estimation, but this time around we are going to use the raw series, the raw prices. We are not going to use the returns. So I'll go again to quick estimate, and here I will just write spot constant futures. Remember previously I wrote arrow spot and arrow futures, which means I was using the returns. But now I'm just writing spot and futures because I am using just the raw prices. And I'll tell you why I'm doing that. So if I estimate, I have my results. Now, I'm going to write the equation, by the way. So this first equation up here was for the return series. Now, I'm going to get the second equation for the raw prices series, right? And I'll tell you why I'm doing that. So the equation should be spot is equals to alpha plus beta futures plus error term. So it will be, since I have here my constant is 21, so I'll come here, instead of A, I'll put 21. I'm going back to A views. And what's the coefficient? 0.98, right? 0.98. After 8, the next value is less than 5, so we cannot round up, we'll round down. 0.98. By the way, how many minutes do we have? 0.98. So I've estimated the equation, so I will delete the error term. Okay, guys, this is our estimated equation using the raw return series. We are not using, sorry, using the raw price series. We are not using returns. Now, what do you notice? You notice that this 0.98 is different from this 0.12, right? So this 0.12 is the optimal hedge ratio, but this 0.98 is not optimal hedge ratio. So to get the optimal hedge ratio, you have to use the return series. So this 0.12 here shows us the optimal hedge ratio, and it also shows us the short run relationship. But now with this second case where we have used raw prices, This 0.98 now shows us long run relationship, right? So the 0.98 shows us long run relationship between spot price and futures price. You need to know the difference. If you are using the return series, the coefficient, that beta coefficient shows you the optimal hedge ratio, and it shows you short run relationship between the returns of spot series and the returns of future series. But if you are using the raw series, raw prices, then that beta coefficient shows you long run relationship, not short run, long run relationship between spot price and futures price. What about this constant, guys? 21. Remember, I did not talk about this constant for return series. We don't care about it. But if you are using the raw price series, this constant tells you something. This 21.
The starting price.
Yes, but I don't want. There is a name we call it because we are doing something here. We are working. We are using derivative market. Normally, the constant tells you what the dependent variable will be if the independent variable is eliminated. That's what the constant tells you, right? But in this specific case, this our constant here is called the cost of carry. You will see it in 503 Ukwanuja towards the end of the semester after the midterm. What is the cost of carry? It is actually the cost of holding a financial instrument. So it can include things like interest costs, storage costs, etc. But it is the cost of carry. Guys, one other thing I'll tell you is, what have you noticed? Look at this 0.98. It's close to 1, right?
Yeah.
It's expected. We expect that in derivative market. When you run a regression, that is where you are regressing the spot price against the futures price, you expect to get a 1-to-1 relationship. What's 1-to-1 relationship? It means if two things have a 1-to-1 relationship, it means they are perfectly related, in the sense that if a change occurs in one, it will perfectly affect the other. That is, they have a direct relationship which is perfect if it is 1. So 0.98 is almost 1, so we expect it. So you notice that the spot price has a 1-to-1 relationship with the futures price, or let's say almost 1-to-1 relationship. And these are the kind of things we expect in derivative market. You expect the spot price to be directly related to the forward price or to the futures price. Understood? Everything fine?
Can you repeat the last sentence? We expect the spot price to go forward?
Yes, generally, because the futures price is calculated from the spot price. The spot price is the price for immediate delivery, and if you want to determine the futures price or the forward price, you use the spot price as a base, and then you try to add some things or subtract some things to get the futures price, right? So actually, what happens is that, let's assume that the spot price today is 10, and then the futures price today is 15. The futures price for delivery in 1 week is 15. What does it mean? It means that we are expecting that in 1 week time, the spot price will be 15. You understand that? What is spot price? I want to buy this pen. I go to the market and they tell me that this pen is 10 lira. I pay 10 lira, they give me this pen now, spot price. Okay, I want to buy this pen next week, but I don't want to wait until next week because I'm scared the price will increase from 10 to 15. So I fix the price with the person selling the price. I go and meet him today and I tell him that I want this pen next week. So we fix the price at maybe 12. That is futures price. You fix the price today, then you pay next week and get it next week. Why are we fixing that price at 12? It is because we are expecting that next week the spot price will become 12. The spot price today is 10. We are calculating the futures price today. but it is futures price for delivery next week, because we are expecting that next week the futures price, sorry, the spot price will be 12. You understand? So there is a one-to-one relationship between futures price and spot price, because we use the spot price as a base to get the futures price. So you expect this. I think that's all. What else should I tell you? I just wanted to, Nigao just said I should show you how we can apply this in derivative market to calculate optimal hedge ratio. I've showed you that. Guys, there's also something I have to show you, but not today. I don't even know when, because I'm following her program. If she tells me show you this, I'll show you. If you notice, we have been interpreting these coefficients. We have been interested just in these coefficients. We have not talked about this statistic, this probability value. Do you have an idea about these kind of things? Do you know what these things are? And we are expected to know. Normally, what we do is we interpret only coefficients which are statistically significant. If a coefficient is, by the way, it's time. Some of you have class, right? It's time.
5 more minutes.
Okay, 5 minutes. I'll finish. Now, when you run a regression and you get this coefficient, our coefficient here is 0.98, right? And we have interpreted it. Before interpreting any coefficient, you have to make sure that this coefficient is statistically significant, which means it is statistically different from 0. If it is insignificant, you don't interpret it. If it is significant, you interpret it. But if you notice, we have been interpreting these coefficients without checking whether they are significant or not, right? That's because for now, Nigahuja just asked me to show you how to interpret these coefficients. But subsequently, we will talk about statistical significance, things like hypothesis testing, and I'll show you how to check if these coefficients are significant or not, because we must check if the coefficient is significant before interpreting it. And in order to check, we are going to use two things. We are going to use the t-statistic and the probability value. With the t-statistic, there is a rule of thumb. If this t-statistic is between -2 and 2 in absolute value, then we assume it is. Let me not complicate it. We'll do it next time. Okay, see you. I'll stop recording.
And the statistics significance, we focus on the variables or also on the constant?
Everything, even the constant. But you know, most of the times we don't even interpret the constant because it's not logical.
Yeah.
But if you must interpret the constant, then it must be significant.
Most of the constant, but I know that most of them are like
most of the times they are not significant.
Yeah.
Yes, but some of them can be significant at times, especially with capital asset pricing model, CAPM model. Yeah. The constant is very important because the constant shows us a risk-free rate. So in some theoretical models, the constant becomes very important. But we'll see it. Okay. See you.
There's no attendance today?
No attendance. Bye-bye. By the way, if you have any questions, you can ask me anytime. Okay.
For example, there are different questions. You just put beside the question that
the grades
this much marks.
Why?
Because last time I just did it late because you said in the class
so that you want to focus on the ones which have more marks.
No. Yeah, that is also important for me. Like
they do everything. Why?
Of course.
So why do you want to focus?
But for example, last time I thought that I should submit the assignment before class because in class you said before class, but then I went to Teams and I went to Teams just a few hours before the submission deadline. And I saw that your deadline is 6 o'clock. So I simply started doing everything and I missed the last part.
Oh.
So
what was your grade?
I think I didn't check. Probably it will be less because I missed the question. So.
What was the student number?
150870.
How many?
150.
21.
You will give me more score.
2150.
8700.
8.
7.
Name?
Ikra.
I.
Yes. KRA. Interrogation. But in English, IQR.
Like this. Okay. No problem. See you.
Okay, assignments. All definitions.
Hold on, let me stop recording this thing. I'll just close it and it'll stop recording automatically. What am I doing? It's still recording. Yes. Save. No. Why is not closing? Oh, I'm supposed to leave.